Hello, welcome to Grafana LGTM Stack course. My name is Mohammed and I'm very happy to be here. In this section, I'm going to do two different tasks. The first task is related to migrating from Grafana Agent to Grafana Alloy, and the second one is working with Grafana Mimir Alert Manager, okay? The first one is more important. Because Grafana Alloy is the new open source OpenTelemetry collector of Grafana, and it's going to be used instead of Grafana Agent because Grafana Agent is now deprecated, and it's highly recommended to migrate from Agent to Alloy. If you probably remember from the previous sections, we used Grafana Agent static mode as well as Kubernetes Operator, and we used different types of resources and configurations of Grafana Agent. And in this section, I'm going to show you how to convert and how to migrate your existing configurations, your existing Grafana Agent configurations to Alloy configurations without any problem, okay? This is the official blog of Grafana, and it explains more details about this migration. And the most important thing within this blog is that Grafana Agent and Grafana Agent Operator, Kubernetes Operator actually, are deprecated and will enter into long-term support from this specific date. And this means both Grafana Agent and Operator will no longer receive any new feature updates, and both of them will only receive critical bug fixes and security fixes, okay? And also, the most important thing here is end-of-life phase where Grafana Agent and Operator will begin once LTS ends, and Grafana Agent and Operator are expected to reach end-of-life on November 1, 2025. And once EOL end-of-life is reached, both projects will no longer receive bug fixes or security fixes. So it means that it's highly recommended to migrate from Grafana Agent to Grafana Alloy before LTS or before end of life of Grafana Agent. Okay, so we need to do that. First of all, I go to the official documentation of Grafana Alloy here. You need to type Grafana Alloy within your browser, and it has a specific section for migration. It's important for migration. If you're using Grafana Agent now within your monitoring architecture, you need to visit this specific section here, and you can see that we have different types of migrations here. For example, migrate Grafana Agent static to Grafana Alloy, or migrate from Grafana Agent Operator to Grafana Alloy. And if you probably remember from the previous sections, we used Grafana Agent static mode as well as Kubernetes Operator, and we need to migrate these two different modes to Grafana Alloy, okay? First of all, let's start with migrate Grafana Agent static to Grafana Alloy. So I click on it, and I go to this page. The most important thing here in this page is using alloy convert CLI command to convert the existing configuration of Grafana Agent as input config path to the configuration of Alloy here, okay? But before that, we need to install Alloy package within our Ubuntu machine. So to do that, I click on install and Linux. First of all, we need to install GPG, but I think it's already exists within my Linux node, but I try it once again. So I type apt install GPG. Okay, it's already exists, so I don't need to install it once again. And then I'm using Ubuntu, so I'm going to use Debian-Ubuntu here. So I copy these lines and paste them here. Very good. And then I copy apt-get install alloy from here, and I enter. Very good. Alloy has been installed within my Linux node. So if I type systemctl status Alloy, it's disabled by default. I need to enable this service, but before that, we need to configure Alloy. Okay. Okay. So I go back to the terminal to disable Grafana Agent. If I type systemctl status Grafana Agent, you can see that it's now working well. And if I go to the dashboard of Grafana, you can see that if I click on Mimir nodes tenant, you can see that we have lots of keys here, and these metrics are provided by Grafana Agent. But I'm going to disable and stop Grafana Agent. So because I'm going to use Alloy instead of Agent, so I type systemctl stop and disable Grafana Agent. Okay, it's now disabled. So when I go to etc Grafana Agent, the YAML, you can see that we used this configuration of Grafana Agent. For example, we're using remote write here to remove metrics remotely to Grafana Mimir, using this specific tenant ID here, the write-ahead log directory, as well as the integrations here. For example, we used node exporter integration here to export and gather metrics of our Linux node and writing those metrics to Mimir remotely. So this is the current configuration of Grafana Agent, and I'm going to use alloy convert CLI command to convert this configuration into alloy configuration. Okay, so let's go back to the documentation of alloy here. You can see that I'm going to use alloy convert here, and it receives two different files and two different paths here. The first one is output config path and the full path to the output to the alloy configuration. And the second one is input config path, the full path to the configuration file for Grafana Agent static mode. This is the current configuration of Grafana Agent, and this is the input config path. Okay. So when I scroll down here, you can see that this is the example. Here you can see that this is the current configuration of Grafana Agent, and it has been converted to alloy config, and this is the final result. Alloy.config will be something like this. Okay, so I need to use this command here. So I copy this line from here and go back here. The input config path is etc Grafana Agent.yaml. This is the current configuration of Grafana Agent I'm using, and the output will be stored in, for example, etc alloy config.alloy. Okay, I'm going to store the converted configuration into etc alloy config.alloy. This is the default path of the configuration for alloy. Okay, so I recommend you to use your converted configuration into this path. So I type it, and when I go to etc alloy config.alloy, you can see that this is the new configuration file, and it has been converted from the configuration of Grafana Agent to the configuration of Alloy. For example, this is the integration node exporter that we used, and the name of the job is integration node exporter, as well as writing metrics remotely to the URL of Mimir. And the header is xscope org.id equals to nodes, and everything is working well. So in this time, I go back to Grafana, and for example, in the last, for example, 1 minute, you can see that we have no labels in the last 1 minute. Okay, it means that there is no collector within our environment to write metrics to Grafana Mimir. But in this time, I'm going to enable Grafana Alloy with new configuration file. Okay, so I type systemctl enable -- now alloy. Okay, and I type status systemctl status alloy, and it's now active and up and running. As you can see here, the storage path of alloy is varlib alloy data, and its default path for the configuration is etc alloy and config.alloy. This is the path that we used for storing the configuration of alloy here. Okay, so it seems it's now working well. And when I go back to Grafana and when I refresh this page, for example, in the last 1 minute, you can see that now we have lots of keys here, and it means that these metrics and these samples are provided by Grafana Alloy instead of Grafana Agent. Okay, so when I go to dashboards, for example, we have a dashboard here called node exporter full. The data source is Mimir nodes tenant, and the host is Ubuntu. Okay, so these metrics are provided by Grafana Alloy instead of Grafana Agent, and we successfully converted the current configuration of Grafana Agent to config.alloy, the configuration of Alloy. Okay, so we learned how to convert Grafana Agent static mode to Grafana Alloy. So the second migration will be Grafana Agent Kubernetes Operator to Grafana Alloy. Okay, so I click on it. Okay. If you have experience working with Grafana Agent Kubernetes Operator, as we exactly did in the previous sections for Mimir as well as Loki, and we used Grafana Agent Kubernetes Operator for both of them, you should know that it has different types of resources, such as Grafana Agent, metric instance, log instance, pod monitor, service monitor, probe, and pod logs. You should know that the monitor types of pod monitor, service monitor, probe, and pod logs are all supported natively by Alloy. It means that they are still valid and you can continue work with them. You can continue deploy them within your cluster without any problem because they're still valid for Grafana Alloy. Okay. But about Grafana Agent and metric instance as well as log instance, these CRDs are deprecated and they are not valid for Grafana Alloy, and you cannot use them if you're using Grafana Alloy instead of Grafana Agent. Okay, it's important. So before installing the Helm chart of Grafana Alloy within our Kubernetes cluster, we need to check the default values of Grafana Alloy. Okay, so I click on default values to check the key value pairs related to Grafana Alloy Helm chart here. Okay. We have many different types of resources here. This is the default values of Grafana Alloy Helm chart. And I think that you should be familiar with these key value pairs here, and you can modify them based on your needs. Okay. First of all, let's start with CRDs that is create equals to true by default. As you know, in the previous sections, we use Grafana Agent Kubernetes Operator, and when we deploy Kubernetes Operator within our cluster, that operator installs CRDs as well. Because of that, those CRDs are now exist within my Kubernetes cluster. To verify that, when I type kubectl get CRDs grep, for example, to service monitor, you can see that this CRD is now available, as well as, for example, pod logs, and it exists as well. So it means that those CRDs exist within my environment because I used Grafana Agent Kubernetes Operator in the previous sections, and the CRDs of Alloy and Grafana Agent are the same. So in my case, I need to set it to false. But if these CRDs are not exist for you, please leave as it is, okay? So it depends on your situation, okay? The second thing that is so important here is Alloy config map. You have two different methods to manage and handle the configuration of your Alloy instance. The first method is this config map create equals to true. When you set it to true, it means that when you deploy this Helm chart creates a default configuration, a default config map for you to be the current configuration of Grafana Alloy. And also, you can change the behavior of that configuration using content here. Content to assign to the new config map, okay? But it creates a default configuration for Alloy, and you can change its behavior using content inside your Helm chart, okay? The second method is setting create equals to false. Whenever you set it to false, it means that this Helm chart won't create a config map for you by default. And you yourself need to handle it. It means that you need to create a separate file as a config map for the configuration of your Alloy instance separately outside of your Helm chart. In this situation, you need to create and apply the config map, the configuration first, and then try to install this Helm chart, because this Helm chart won't create a config map for you if create equals to false. Okay, so you have two different methods. For this example, as I want to do, I prefer to set it to false and create our own configuration here. Okay, so I prefer to use the second method. And the listen address, the default listen address is this, the listen port is this, the listen schema is HTTP here. For Grafana Alloy, you can change them based on your needs if you want. And another thing that is so important is config reloader. This is so important. This enables automatically reloading when the Alloy config changes. For example, let's imagine that we have a separate config map and we have a separate configuration for our Alloy instance. And whenever we update and modify this configuration, the configuration of our Alloy container will be reloaded as well. Okay? So it's so important to set enable equals to true. It's so important. And another thing that is so important here is controller. The controller type by default is daemon set, but you can change it to deployment or stateful set. Deploying Alloy as a stateful set is a recommended option for Prometheus metrics collection, as I want to do here in this example. And when you set it to stateful set, the persistent pod identifiers make it possible to consistently match volumes with pods so that you can use them for write-ahead live directory, okay? For example, in my current situation, I want to use service monitors to scrape metrics from kube latency advisor endpoints. And actually, I'm going to use Prometheus metrics collection. So I need to change the type from daemon set to stateful set. Okay. You can also use a Kubernetes deployment in cases where persistent storage is not required, such as traces-only pipelines. And the next type is daemon set. The default type is daemon set as well. And it's so useful when you want to gather and when you want to get the host level metrics and logs, okay? So you can change it based on your environment. But daemon set is so useful for host level logs and metrics. So, okay, let's go back to the terminal and I go to Alloy-metrics here. We have different files here. First of all, let's start with alloy-values.yaml, where I modified some default values of Grafana Alloy Helm chart. So let's open the file. Okay. First of all, let's start with CRDs criticals to false, because those CRDs exist within my cluster, so I don't need to install those CRDs once again. Because of that, I set it to false. But for your case, please check your cluster to verify those CRDs exist, and then change it based on your needs. But its default value is true, okay? I changed the controller type here as well from daemon set to a stateful set because my needs, for example, I'm going to collect Prometheus metrics, and I'm going to use a persistent storage for write-ahead log directory. So I prefer to use stateful set here. And one thing that I forgot to mention here is volume claim template. So I'm looking for volume claim template, yeah, here. Volume claim templates. Volume claim templates to add when controller.type is a stateful set. It means that you can set your volume claim templates here for your stateful set controller type, okay? But we are using Grafana Alloy within our test environment, so I don't need to set it here. But if you're going to Grafana Alloy within a production environment, and if you change it to stateful set, you need to set volume claim templates here within your Helm chart, okay? This is so useful when you're using stateful set as the controller type. And also, as I said earlier, I'm going to use the second method for Alloy configuration. It means that I'm going to create a separate file, a separate configuration, separate config map for our Alloy instance. Because of that, we need to set the config map create equals to false instead of true. And in this situation, whenever you deploy this Helm chart, that Helm chart won't create a default config map for you because it seems that you are using a separate config map outside of your Helm chart. Okay? So the name of the config map that I'm using is alloy-config, and its key is config.alloy. Okay? We're going to use this config map, okay? Very good. So let's go back to the official documentation of Grafana Agent to show you something. In this page, migrate from Grafana Agent Operator to Grafana Alloy, we have a very important section called Convert Metric Instance to Alloy Components. As I explained earlier, the type of resources such as metric instance, log instance, and Grafana Agent have been deprecated, and we need to convert them to Alloy components. And in this case, I'm going to convert metric instance to Alloy components, okay? So to start working with Alloy configuration, you can copy this config file here as a template and try to modify those lines. You need to change them, okay? So I did that already. So I have a file here in this directory called alloy-config-map.yaml. So I open it. As you can see, its kind is config map. And this config map includes the current configuration of our Alloy instance, okay? The name of the config map is alloy-config, and the namespace is Alloy. So this config map is going to be deployed within alloy-metrics namespace, okay? We have three important sections here. First of all, I'm going to mention here that the name of the key inside this config map is config.alloy, and its value is the actual configuration of Grafana Alloy here, okay? And this configuration has three important sections. The first section is Prometheus.remote-write, and the name of this resource is Mimir. It's not required. You can change it if you want. For example, in this template, the name of the resource here is primary, but I preferred to change it to Mimir. And we have a block here called endpoint. And also we have URL, and the URL includes the URL of our Mimir cluster, mimir-nginx.mimir.svc.cluster.local, okay? And so this is the URL of Mimir. And another thing that we have here and is optional, it's not required, but optional, is headers. Whenever you want to add a specific header within your post request, for example, you can specify your headers here. For example, I'm going to use xscope org ID equals to pods, and it means that the metrics and samples sent to Mimir are going to be stored within this tenant ID. And the tenant ID is pods, okay? The second resource and the third resource actually are the same, but with a little difference. The second resource is prometheus.operator.podmonitors, and the last one is prometheus.operator.servicemonitors. If you pay attention to these two different resources, you realize that the Grafana Alloy is going to discover all pod monitors and service monitors within our Kubernetes cluster, which include a specific label. And the label here, for example, is instance equals to primary. You can change it if you want. But this label specifies that Grafana Alloy is going to discover all pod monitors and service monitors of the cluster that include this label. Okay? So when I go back here, as you can see, we have two different service monitors here, Kubelet service monitor and cAdvisor service monitors. If you know, service monitor is responsible to scrape metrics from Kubelet and cAdvisor endpoints. And when I open one of these files, for example, cAdvisor service monitor, its name is cAdvisor-monitor. And the namespace will be, for example, alloy-metrics. But the most important thing about the service monitor is its label. The label here is instance equals to primary. And this service monitor is going to be discovered by Grafana Alloy because it's using this label. Okay, it's important. And I changed the default namespace from here, from alloy to alloy-metrics, okay? And as you can see here, this service monitor is using this label here as well. So first of all, I create a namespace called create NS alloy-metrics. And then I try to deploy these two service monitors inside alloy-metrics namespace, cAdvisor, as well as Kubelet cAdvisor. So when I type kubectl get service monitor -n alloy-metrics, you can see that we have two different service monitors inside alloy-metrics, and both of them are using the same label, and the label is instance equals to primary, and it means that both of them are going to be discovered by Grafana Alloy, and it's so important. So the name of the resource that I'm going to deploy is alloy-cm.yaml, the config map, the configuration of our Alloy instance. So I type kubectl apply-f alloy config map, and when I type kubectl get config map-n alloy metrics, you can see that this config map has been deployed inside alloy-metrics, and it's going to be the live configuration of our Alloy instance, because whenever we deploy, we modify and update this config map and this configuration, the configuration of Alloy container will be reloaded as well based on the changes here. Okay, so it's going to be the live configuration of Alloy. So let's deploy and install Grafana Alloy inside our Kubernetes cluster using this command helm install alloy-metrics Grafana /alloy -n alloy-metrics and -f alloy values.yaml. Very good. So it has been deployed inside alloy-metrics. So when I type kubectl get pod-n alloy-metrics, you can see that Grafana Alloy has been deployed, and actually this is a stateful set workload. The controller type here is stateful set, and it's now up and running, and it looks great. So when I type kubectl logs-n alloy metrics, these are all logs related to this workload. So we deployed Grafana Alloy using the controller type of stateful set. And so when I go back to the instance of our Grafana here, for example, home, explore, and I choose Mimir pods tenant instead of nodes tenant to see all samples and metrics related to Kubernetes pods. And when I click on select label, you can see all labels, all keys related to our Kubernetes pods. For example, I can select namespace from here, and it shows all namespaces that we have within our Kubernetes cluster. So for example, when I choose namespace equals to Mimir, and when I click on run query, it returns all metrics related to this namespace, all pods of this namespace as well. Okay, so it seems that it's working well, and we successfully integrated Grafana Alloy with Grafana Mimir, and we converted metric instance, a type of resource, to Grafana Alloy components, and it was very, very good. So the next thing that I'm going to use in this section, is Alert Manager, and using Grafana Mimir Alert Manager. Okay, so let's go and work with Grafana Mimir Alert Manager. As you know, we are using multi-tenancy in Grafana Mimir, and right now we have two different tenants, nodes and pods. Okay, so we need to specify pertinent alert manager configuration. So it's so difficult. For example, let's imagine that we have 10 different tenants, and so we need to define and specify 10 different alert manager configurations. So it's so difficult to handle and manage all these configurations. Okay, so to solve this problem, Grafana Mimir has provided feature called Alert Manager Fallback Config, which allows you to define a default alert manager configuration, and that configuration can be used by any tenant you have in Grafana Mimir. Okay, so it's very, very useful. So I'm going to show you the default values of Grafana Mimir Helm chart. So I open my Visual Studio Code, and these are all key value pairs related to Grafana Mimir Helm chart. Okay, we have a very important section called fallback config, and using this block here, you can define the default configuration, the default alert manager configuration, and this section is under alert manager block. Okay, we need to modify these multiple lines because they're not suitable to use. So we need to modify them based on our real receiver, based on our real contact point. And this configuration can be used by any tenant. Okay, so whenever you deploy and install Grafana Mimir within your Kubernetes cluster, this alert manager configuration can be used by any tenant you have. So it's very, very useful. So I did that already. So when I go to my terminal, when I go to logs Loki, we have a file here called Mimir values new. I used, if you remember from the previous sections, I used this file to deploy and install Mimir within our cluster using modified and updated key value pairs. So one of the components that we modified was alert manager fallback config, and we configured our real contact point, our real receiver under this important block. In this example, I'm going to use my Mattermost channel to receive any alerts. And the channel I'm using is alerting. So let's go to the browser and go to Mattermost local. This is my Mattermost instance, and I have created a channel here called alerting, and this channel will receive any alerts from Grafana Mimir. Okay, so we are using an API URL here, and the API URL includes the URL of Mattermost as well as a token as an integration API here. So we need to change this token. We need to change this URL because this URL has been changed, for example. So when I go to integrations and incoming webhook, I created an incoming webhook within my Mattermost instance. So I need to copy this URL and use this new URL here instead of the previous API URL. Okay, so any alerts are going to send to this API URL and in this specific channel, alerting. Okay, and its name will be, for example, Slack notifications, and the receiver is Slack notifications as well. Okay, so when I go to my Grafana instance, and when I go to, for example, alerting section and contact points, you can see that we have a contact point here called Slack-notifications. This contact point has been deployed when I deployed Grafana Mimir within our cluster, because I used this block here. And so when I type kubectl get config map -n Mimir, you can see that we have a config map here called Mimir alert manager fallback config. And this config map includes all configurations I provided within this file. So I type kubectl get config map -n Mimir -o YAML. And yeah, alert manager fallback config.yaml includes this contact point here, the receiver, as well as the channel, API URL, title, and text, the template of the message here. Okay, so I configure and I modified my fallback configuration using a Helm chart, and you need to modify fallback config here based on your real contact point and real receiver. Okay, so let's go to Grafana to create our first alert rule using our new Grafana Mimir alert manager here. But before that, we need to update the Helm chart of Grafana Mimir within our cluster because the API URL of Mattermost changed. Okay, so I go to my terminal and I type helm upgrade Mimir Grafana Mimir distributed -f Mimir values new.yaml. Okay, the new Helm chart has been deployed. So when I type kubectl get pod -n Grafana Mimir, as you can see here, the new instance of Mimir Alert Manager has been deployed, and I'm going to wait for it to be up and running, okay? Okay, it's now up and running, and so now let's go back to alert role here to create our new role. So I click on new alert role here, okay? In this alert role, I'm going to evaluate the memory status of my node, okay? Because of that, first of all, I need to give it a name, and the name is host out of memory. Very good. The second step is defining query and alert condition. First of all, we need to specify a data source we're going to use, and the data source for this alert role is Mimir nodes tenant, okay? We need to enter a PromQL query to evaluate a condition. So I have a pre-ready role within roles.yaml file. I copy these 2 lines and paste it here. Very good. This PromQL query evaluates the memory status of my Linux node, and it goes to a firing state whenever it detects that the node has less than 10% left on the memory. Okay? So when I click on run queries, it returns no data. It means that we have no problem related to memories of inside my instance, and it seems that everything is good. But for example, whenever I change this value from 10% to, for example, 50%, and when I click on run queries, it returns an instance. It means that this PromQL query evaluated the memory status of my Linux node, and it detected an instance which has less than 50% left on memory. Okay? So whenever you create this alert rule goes to a firing state because it detected an instance which match with this PromQL query. Okay. We need to specify the rule type, and instead of Grafana manage, I can use data source manage here. Very good. The third step is set evaluation behavior. And 1 minute, I think, is ideal for this example. And this is pending period in which an alert rule can be in breach of the condition until the alert rule fires. And 1 minute is good. I leave it as it is, so there is no problem with it. We need to specify a namespace as well as a group. For example, the namespace will be nodes, and the group is memory, for example. Okay. Configure labels and notification. I set the label to the key is memory, and the value is, for example, filling up. Add an additional label here is severity equals to warning. Okay, so I added 2 different labels, 2 different key value pairs for the labels, memory filling up and severity warning. Okay, we need to enter and type summary as well as description for my alert rule. And I did that already. So the summary is this host out of memory. And description is node memory is filling. Okay. I changed 10% to 50%. Because of that, I need to change the description here as well. For example, 50% left here. Okay. So this alert rule goes to a firing status if it detects that my node has less than 50% left on memory. Okay. So it seems good and it looks great. So I need to save rule and exit. Okay. The rule has been created and it's creating. So I need to wait for it. Okay. As you can see here, its state is normal, but I need to wait for a few seconds to see that its state is going to be changed from normal to firing because it detects an instance which matches with the alert condition. Okay, yeah, the state has been changed to pending, and after pending, it goes to firing state. And whenever it goes to firing a state, an alert is going to be sent to my Mattermost channel here, an alerting channel that we have here. Okay. So I need to wait for this alert rule to go to firing state. Okay, as you can see here, the state of this alert rule is firing. And when I go back to my Mattermost channel, yeah, you can see that we have a new message within this channel. The title is host out of memory for instance Ubuntu. And the description is this: node memory is filling up, less than 50% left. The values as well as labels. So it seems that the alert manager of Grafana Mimir is working well, and we have no problem for that. I think that I covered all required topics of Grafana Mimir in this section. We talked about Grafana Mimir architecture as well as its features such as multi-tenancy. We worked with multi-tenancy as well. And we worked with Grafana Mimir Alert Manager. And also we learned how to write metrics remotely to Grafana Mimir using Grafana collectors such as Grafana Agent, migrating from Grafana Agent to Grafana Alloy, and I think all topics covered in this section. So thank you for watching. I hope you like it, and see you soon in the next section.